Well, hello, everybody. Welcome to another episode of Communications and Conversations. We are back. We have not been forgotten. Kind of like the rash that doesn't go away, or you think it goes away and it comes back. We are back here on the show. Thanks for tuning in today. Today's topic is going to be a little bit of a fun one. We're going to dive back into digital voice. We're going to do the 10,000 foot layer of digital voice. I saw a lot of people this past weekend in Hamcation, and we got to talk a little bit about digital voice. And there was some really good conversations on there with some of the people. I know I didn't have a camera in their face or anything like that. Like, you can have conversations and come back and report. You don't always need a camera on people's faces. But I did have my body cam there, which after the last episode, man, that really did it. I think some people listened to my episode more than they know, because there were a few people that did not in any way, shape, or form come near me that normally did. So I'm okay with that. So welcome to, once again, the episode of Communications and Conversations. I'm your host, John Crook, wearing my other multiple hats of things that I normally wear. And like I said, today's topic we're going to talk about is digital voice. We're doing a 10,000 foot layer of digital voice from the proper perspective, is the way I'm going to go ahead and call it. That's a little opinion, I guess, on there, because we're going to look at where digital voice kind of came from and kind of have a little bit of a discussion on it. Now, I'm not going to have any graphics on there or anything, because guess what? There's a lot that we can get into on there. But we're going to kind of talk and understand where they came from, how they came about. So without further ado, we're going to jump into today's episode. But prior to doing that, I want to go ahead and talk about our sponsor, which is JJK Communications. That's right. JJK Communications is the sponsor of Communications and Conversations. They are the ones that help keep the light bill on, that help keep the internet feed, that and have great products to kick off here. They even are, as you see here of the picture, if you're watching on our YouTube channel, talks about the JJK Elite system. That's right. JJK Elite systems from JJK Communication allows you to have two-way radio communication connections, whether you're locally, regionally, or even across the U.S. using push-to-talk over cellular services. Now, what is different than all these other push-to-talk cellular services ads and stuff that you see on there? Here's what it is. You are getting JJK Communications product and service that they are selling, but then also, too, is you get backing and understanding. They're not going to give you false hopes or pretenses or anything and saying, hey, work everywhere and during hurricanes and this and when other radio systems fail. No. JJK Elite helps supplement it, and then they can also set you up on systems that allow you to, once again, communicate locally, regionally, nationwide, and also cross over to traditional, proven two-way radio networks. In addition, it doesn't need to be these push-to-talks. You don't need cellular connections to do these. These radios can be set up to work on IP-based connections, which does not require that cellular stuff. Don't want to rely on Verizon, AT&T, T-Mobile, or whoever you're using on there. JJK Elite systems can still work without the usage of cellular networks. And we're not talking RF with like FRS radio frequencies or anything like that. No, using other types of access to the system, it is capable to do that. If you have more questions or want more information, reach out to JJK Communications. They can be reached at their website, www.jjkcom.com. That's jjkcom.com. Alrighty, so what are we going to talk about today? We are going to talk about the world of digital voice, and we're going to cross both realms of the world of digital voice. So we are going to actually cross over not only the commercial-based stuff, but some of the amateur-based stuff out there, because there is some confusion out there on the different modes that are out there, are capable, all these kind of things like that on there, that you need to understand that digital voice is flexible and kind of has different aspects of it. So that's what we're going to talk about today. Now, when we talk about it, we are going to delve into not a super technical thing. So if you're listening and being super technical on there, we're not going to get into it. We're going to kind of describe on today's episode about how each of them are unique in a certain way or certain means. Now, we don't endorse, or I'm not going to endorse one digital voice mode. I'm not. I'm going to tell you, have I used this mode ever, or have I not used this mode on there, and to kind of give you that understanding. But what I'm going to definitely tell you is I'm not going to give you an opinion. The whole point of today's episode is to form an opinion based on what you think is the best. And I'm going to tell you this, okay? I'm going to tell you hands off and hands down. I have a bunch of radios here, too many to show right now, but they all cover the majority of the modes that I'm going to talk about today. One specific mode is not going to be better than the other. I'm going to tell you that hands down. I hear that argument, that conversation, that point so many times of people like, if we just agreed on one digital mode, there would be no problems. BS, there's not, okay? Why do we have different car manufacturers and car companies? Because each of those bring to the table a different sort of option, variants, those kind of things like that on there that make their car, that make their vehicle better than the others. And that's truly what it is, okay? Once again, there's not going to be any sort of perfect mode. I know a lot of people say that there is. There isn't. I'm sorry. There isn't. And that's what I'm just going to tell you there. So, without further ado, let's dive into this real quick. So here's what it is. We're going to start out on the first mode out there, which kind of seems to resonate as the most common digital voice mode on the commercial side. So we're going to start out on the commercial side. Now, do some of these modes cover into the amateur side? Yes, but what I'm dividing today between commercial versus amateur is going to be ones that are actually designed for commercial applications versus designed for amateur applications. And as you'll see in the list, commercial does cross to amateur, but amateur doesn't really cross over to the commercial world. Now, there's a wide probably variety of reasons for that. The biggest thing is that a lot of the amateur stuff is not designed and used in Part 90 radios. Yes, here we go again with that Part 90 stuff and Part 95 and Part 97 stuff. Right. So Part 97, remember, is amateur-based type of rules and regulations on there. Part 90 is the LMR type thing on there. Now, we're going to just really quick to understand type on there. You know, people saying, there's no Part 97 certification on radios. There is and there isn't, okay? There isn't. While a radio may not be Part 97 stamped, they are designed to the operational standards of Part 97, which is different than the operational standards of Part 90. So that's a big understanding that you have to do when you come into digital voice, because some people will say that, well, why do we do digital voice? Why are we doing this? Why aren't amateur radio companies making, DMR or P25, those kind of radios? Because of the way it's designed. One of the biggest things I'm going to tell you right now about Part 90 radios is that Part 90 radios, at first, when they are delivered to you, they are not supposed to have FPP or front panel programming, keypad programming, whatever you want to call it, enabled. And two, they need to go down to the 2.5 kilohertz channel stepping. Okay? So there's 5 kilohertz is usually the lowest one on the amateur radios that are actually amateur radio designed. 2.5 is business. Okay, it needs to step down more granular than the 5 kilohertz. 5 kilohertz, obviously 2.5 is half of that on there. And the reason being is because that's why digital modes are becoming so popular, is because it meets that narrow band requirement, and we could fit more people into a channel space on Part 90 frequencies than we really have to worry about on the amateur band frequencies. So, starting out, DMR. DMR stands for Digital Mobile Radio. And unlike some YouTubers, I will stress that, it was not designed by Motorola. It was not. DMR comes from the ETSI, and I'm talking ETSI, European Telecommunication Standard Institute, not the ETSI like I can buy a crocheted oven mitt, ETSI, okay, ETSI, as a digital voice standard. And the standard came to the concept of how can we spectrally and efficiently utilize the RF band portion on there. And what they said is with DMR is we go by what they call time slots. So for today, when we're talking about digital voice, I want you to think of it as this regards. I want you to think of a way to send a signal down the road. We're going to pretend each frequency is a road. So I can either send it like a car driving straight down the road, okay? Or, and let me go there, and how wide the road is. Or I can still imagine it that I'm sending a signal, a car down the road, but in this case, it's a fixed lane, and I'm going to try to see how many, and if you're watching the YouTube, how many cars I can fit bumper to bumper in those lanes, those fixed lanes. Other digital voice modes are saying, you know what, I'm going to send as many cars as I want at any time down that road, but the road may be 2 lanes, 4 lanes, 6 lanes, 8 lanes, whatever the case may be. So do we fit a car bumper to bumper, or do we see how many cars we can fit side by side? Those are the two big differences between the two digital voice modes. And how many cars we can fit bumper to bumper is really called TDMA. It stands for Time Division Multiple Access. Okay? How many cars I can fit side by side. So not bumper to bumper, but like side to side, like if 2 cars were parked right side next to one another. That is called FDMA. That's Frequency Division Multiple Access. That basically is saying, hey, I'm going to fit a digital signal down, but I need more lanes to do it possibly than trying to put bumper to bumper in 2 fixed lanes. So that's the biggest difference on there. So DMR uses TDMA. And the way DMR says that they are efficient, because that's why you go to digital voice, because of efficiency, is because they say is that with the time division, we are in essence putting 2 conversations down the frequency at one time. And that's where they come in to call time slots. And the time slots basically have time slot 1 or time slot 2. And what it does is it syncs the information. So when you key up a DMR radio, and you're doing simplex or repeater or trunked, whatever the case may be, you're keying that radio up. And what's happening is when you get that chirp, that means that you're saying your radio is calling out to the system or whatever you're trying to talk to and saying, hey, I'm on time slot 1. Do you hear me? And that other device replies back and says, yes, I do. Okay, the radio that's transmitting, my radio saying, okay, now I can talk because I know I'm in the right time slot. If the time slot's not available, or I can't hear the other station, or I don't get that ACK back, then what ends up happening, guess what? It's not going to transmit because it says, hey, you can't hear me in time slot 1. Is that because time slot 1's busy? Is that because you can't hear me? Because it's syncing, okay? It's timed syncing. When a DMR radio goes ahead and keys up, in essence, your radio is keying on and off at 30 milliseconds. That's why if you've ever listened to a DMR transmission on an analog scanner, you're going to hear that motorboarding noise, because what's happening is it's keying on and off every 30 milliseconds. Backing off, okay? And when it keys, it's keying into that time slot. When it unkeys, it's giving room for that other time slot. So why is DMR popular? Well, DMR is popular because what it's using, if we go back to that analogy of the road, it's using a 2-lane road, in essence, but the cars are bumper to bumper on that road. So what's happening is what we mean by that is that if I'm talking on the 1 frequency on time slot 1, someone else can be on that same frequency on time slot 2, and our conversations aren't bumping into one another. Because I'm on time slot 1, so like lane 1, let's say for argument's sake, and they are in lane 2 for argument's sake. So that's where DMR is doing. Now, bandwidth. We get into that bandwidth. I talked about channel stepping and everything. Bandwidth is still 12.5 kilohertz. Okay? But what's happening is that you're staying on, in essence, at the certain bumper-to-bumper traffic, so you're kind of covering both lanes. If we look at 12.5 being 2-lane highway and like 25 kilohertz, which is like an analog amateur frequency, as being 4 lanes. Okay, what it's saying is, yeah, I'm using 2 lanes, but we're bumper to bumper, so we're not going to interfere. So that's DMR. Now, DMR is popular because of the granularity of how it can get complex. So you could do simplex, right? Simplex, obviously, or radio to radio, direct, TAC, whatever you want to call it. You can go radio to radio. But DMR also then allows you to use repeaters. Now with the DMR repeater, once again, you have that time slot. So you can have two people simultaneously using that repeater for communication on there at the same time. That's why people say it's efficient. Other digital voice modes don't have time slots. So that means if I'm talking on the repeater, someone else wants to use that same repeater, then I have to unkey and then they can talk into it. All right. Not with DMR. DMR, I can be on time slot 1, someone can be on time slot 2. Now, with that being said, you have color codes of the repeater, and the color code is basically sort of like a access tone to the repeater. If you don't have the right color code, then it's not going to allow you access to the repeater. Now, then you also have talk groups. So what you do is, this is where that granularity comes down, okay? I can be on time slot 1, but that doesn't mean everybody on time slot 1 is going to hear me. Only those that use a talk group. Now, a talk group, kind of a star note here, footnote. What is a talk group? A talk group is a number assigned to people's radios that when they push the talk button, that radio will transmit on that number, and then only the people whose radios are programmed with that number will hear you. So in other words, if I'm on time slot 1, talk group 100, let's say, only people who are on that same frequency or repeater listening on time slot 1 with their radio program to talk group 100 will hear me. If someone is using, let's say talk group 200. So if you're on time slot 1 and talk group 200, you're not going to hear me because I'm using talk group 100. Now, the talk groups are not per time slot either. It can be based on the different slots. So you can have people on talk group 100 time slot 1, and you can have a completely different group of people on talk group 100 but time slot 2. So therefore, you have the dual conversations that are going on and taking place on there. So that is that aspect on there. So that's why DMR is really favorable. Now, once again, granularity, the expansion system, in conventional mode, you can actually link repeaters together or connect the two repeaters together. So then that way you can then start to get routing of the talk groups. So in other words, let's say I have repeater 1, 2, and 3, okay? And with repeater 1, 2, and 3, let's say it's like, okay, if I'm on repeater 1 on talk group 100 on time slot 1, it's only going to stay on that repeater. But if I'm on time slot 2, talk group 100 of repeater 1, that may go from 1 to 2, okay? But then a different talk group on a different time slot may go from repeater 1 to 3, and a different one on a different time slot on a repeater 2 may go to 2 to 3, and then they might open them up all, and so it really can get designed and overlapping. And really what the concept of DMR, part of the ETSI standard is to say that you could actually connect sites together and be able to communicate without having to always be connected to the other sites. And a good example I'll give is, like, let's think of a hospital, okay? And let's say the hospital has 3 different campuses, all righty? And if I'm on campus 1 and I'm a maintenance guy, I may only need to talk to my campus, all righty? But let's say I'm at the hospital and I'm the head of security, and I oversee the security at the hospital campus and campus number 2 and campus number 3. Well, then I might need to say, like, whoa, wait a minute here. I need to talk to my security staff at the hospital, campus 1, so I'm going to talk to them there. But then maybe I might need to talk to the campus security at hospital or campus number 2. Well, now with DMR, if the sites are connected, I could take my radio, turn to a different channel, and that might be campus 2 security. I can turn to that, and now being on the campus 1 repeater, because of DMR and the way it links and operates, I could talk directly to campus 2 security. I could talk to campus 3 security. For that matter, I may even be able to talk to all campuses at one time for my security on there. So that's the appeal to DMR. Now, DMR has a lot of integration of networks. There is the ability to link repeater to repeater or site to site, whatever term you want to use on there, where it's only those two. There are designs where you can link into a server. There's hybrids where you link into a server as well as you link into a talk. So there's a whole bunch of different things on there. There even is standards for trunking, which I'm not even going to get into that right now, but understand that you can have sites linked and roam and all this kind of cool stuff like that on there. But that's why DMR is really kind of unpopular in the business world on there. Now, Motorola did not start DMR. The ETSI standard did. Did Motorola bring the DMR world over to the United States? Yes, they did. Did Motorola, as usual, put that little spin on there? Yes, they did. All righty. But they built the DMR standard to a DMR standard. They add features which are only Motorola proprietary, but DMR is not proprietary in that regards. You can take a Motorola DMR radio, use it on a conventional system or repeater, and talk to, let's say, an E.F. Johnson, or let's say a Kenwood, let's say God, there's so many places. Any tone, whatever. You can do all those kind of things in there because DMR at its core does operate to a standard. But it's like Motorola adds little spices of their little flavor that, oh, no, you got to be on a Motorola system with their radios in order to be able to do this. E.F. Johnson, Kenwood do the same thing also, too. Everybody has their little spin on it, right? Okay. Now, next mode we're going to talk to you is about P25. So P25 is a APCO standard. So the Association of Professional Communication Officers, they went along, and when the world was starting to come into digital voice, so we're talking back in like the 90s now, the mid-90s, they said, we got to get a board and we got to get a standard across the board. Otherwise, what's going to end up happening is that everybody's going to be using their own little digital voice flavor on there, because you'll hear there's a bunch of them, and they're going to say, like, then we're not going to be able to talk, right? So APCO, which, once again, is APCO, had different standards. They actually had APCO P16 standard, which dealt with some trunking and those kind of things on there. And then they came up with the P25 standard. And that's where the word P25 comes from, okay? In essence, P25 is a C4FM FDMA type technology. Going back to DMR, that's 4FSK FDMA. Okay, so as you see, P25 is C4FM FDMA, so different. And you see the two aren't going to talk to one another. I can't take a DMR radio in digital, and I can't take a P25 radio in digital, and the two talk together. It doesn't work that way. But anyways, P25 said we're going to come, the APCO said we're going to come up with a standard on there. If you're going to be in public safety, this kind of thing, this is the national standard you should adhere to, using C4FM and FDMA. How FDMA goes? FDMA is, once again, lining up cars side to side. So the driver's side door is going to touch the passenger side door of the other vehicle, and vice versa. Just, think of like a line of cars, like Evel Knievel is going to jump. I probably just dated myself there too. But so when you have that on there for P25, what's going to happen in that case then is that it's going to operate single lane, no time slots, no nothing on there. But what P25 does is they operate with what they call NAC codes and talk groups. So NAC codes are like that access code tone on there. So once again, if we go back to like PL, DPL, CT, CSS, DCS, digital doesn't have analog in there, so that's what these codes do. And NAC, stands for Network Access Code. So as long as the network access code of your radio matches the other radio and the talk groups match, you'll hear one another on there. Now, same thing like DMR, P25 has talk groups. And talk groups allow you to filter things out even more. More so, though, with P25, the reason of a talk group is more so for routing, okay? So let's go back to that example of that security officer at the hospital campuses. If they're using P25, what's happening is that their access code might be 293. That's the common one. I don't know why it is, but that's the common one, 293. So 293 may access all the three different hospital campuses repeaters, okay? But if the security chief wants to talk to his campus security there, he may use talk group 100, for an example. And if he wants to talk to the second campus, he can go into the same repeater, and then he could use talk group 200. Maybe. And then if he wants to talk to the campus security at campus 3, he may go in the repeater and use 300. And then let's say he wants to talk to all of them. Let's say he may use the talk group of 400, and that will key up all the campuses all at once. Now, the thing about that is that talk group usage, is not. It is used in some P25 systems. It's used more in trunking than it is conventional, but it still can be used in conventional on there. This is where you're looking at P25 systems. They have a lot of talk group numbers. And that is a little different in the trunking system because you have multiple users going in, and then that routes out who hears it. That's what a talk group does. But in trunking, it plays more of an important part because not only do you get access to the system through your NAC codes and stuff like that, but in trunking, it's going to kind of listed out by a priority, those kind of things like that on there. You can actually have talk groups that have lower priority on a trunk system than other talk groups for obviously a variety of reasons, right? If the local, public works department has 3 talk groups and talk group number 3 is the lowest public works priority talk group, you don't really need that one trumping the actual users of law enforcement as their main channel talk group, right? So those kind of things there. But that is P25. Now, P25 has a very high fidelity audio level on there. That is why is part of its standard. So it currently uses, even in trunk systems, it uses FDMA, but it's a 12.5 kilohertz bandwidth. So it sounds very crisp, very clear on there. The radios are actually designed, and the protocol is actually designed that you can have a firefighter standing right next to the engine, fire engine going ahead and doing pump operations, and then normally there'd be like a noise of the pump. Well, P25 is designed with obviously radio manufacturer standards and little spins that they put on there to really cancel out that background noise to make that audio come through. And if you've ever heard of a digital signal in public safety, odds are it's probably going to be P25. There are a few other ones that are out there that are very similar but not, and have good audio but not like P25 on there. Now, that's kind of it for P25. Pretty standard, pretty common across the board. Not too much to talk about P25. Now, NextDen offers a sort of like a P25-esque. It's like a cousin, one could almost say. Because what NextDen does is very much the similar things that P25 does. But NextDen, if we're putting cars together, NextDen allows the cars to be even in smaller lanes than what the P25 is. Okay? So NextDen goes down to 6.25, so half of the lane size that P25 needs to use. And in that regards, they can compress that audio more, but still have it sound good. Now, NextDen is a C4 FM FDMA type technology also, but instead they use what they call RAN codes, which is random access number codes, okay, or repeater access number codes too. There's a couple different variations on there, but what those are is basically like a NAC code, like a color code, like a CTCSS. You have to have the right RAN code in the radio to talk to the other people that have the right RAN codes. And then in addition, they also have talk groups on there. Not really big difference on there. NextDen is a Kenwood creation sort of on there. ICOM has a version called IDAS on there, but with NextDen, you can operate in 12.5 and 6.25. So you have actually more. I hate to say that more because it depends on how you do it. So for an example is that on a frequency, if you're at the center of the frequency, you're adjusting how wide it is, right? Okay. So if you go 12.5 kilohertz bandwidth on there, what you do is you, in essence, from the center part of your frequency, you have 6.25 to the left and 6.25 to the right. Well, if you condense down to 6.25, the center part of your frequency is going to be at the middle of the 6.25. Now what ends up happening in essence is if you have a 6.25 and you divide that by 2, what's going to happen is that you only have 3.125 to the left and to the right. But what this means is that you can actually create more individual frequencies. So what it is that you can get more granular. So in essence, in that same 12.5 kilohertz spot on there that P25 is, NextDen at 6.25, you can put 2 conversations in there, but it's not like DMR, Okay, it's not like DMR. DMR uses 12.5 with time slots. NextDen uses 6.25, but you can nestle them in together, and then what you're doing is you're doing that frequency. You're doing the road. You're not, door to door, not bumper to bumper. Now, NextDen, like I said, there is somewhat of a European standard on there. NextDen it's been out there for a while, but it really hasn't caught on too much. And I don't know why. Some systems will use it. NextDen is very popular. They right away, they came out with standards right away for trunking, and NextDen trunking is very popular. There's, by me, as a matter of fact, there's actually a couple different NextDen trunking systems out there. But, I mean, you think about it, NextDen is a little bit more spectrally efficient, and you don't have the issues with the time syncing that you do with DMR, right? Remember, you got to key up and you got to be right that slot, so there has to be that time sync where NextDen just goes, right? There's no time syncing or anything like that needed on there. Now, why is NextDen kind of nice for trunking? Well, back in the days, there used to be a analog voice system, which still is called LTR. And LTR was an analog system out there, or Motorola even had some, they call them, what was it? I'm going to get yelled at here, but like Type 2 trunking, Smart Connect, Smart Zone, Smart Net, those kind of things like that on there. Those were analog trunking. But if you think about it, back in the days when it first started out, that was analog wideband channels. So that, in essence, was 25 kilohertz. We'll just do the math there. If you had a 2-frequency or 2-channel trunked radio system that was 25 kilohertz back in the day, you had to obviously narrowband. Well, then that took it down to 12.5. But if we go back to the day of the 25 kilohertz, you could fit 4 NextDen conversations in that 1-frequency bandwidth. Okay, like I said, they went narrowband, which went down to 12.5. Well, okay, even in still 12.5, you could still hold 2 NextDen conversations in there. Now, this is where NextDen and DMR have fought with one another, and I think DMR wins just because there's more people making DMR radios. But in that case, you take a look and people saying, well, in that same frequency bandwidth of 12.5 kilohertz, I and DMR can have 2 conversations, where NextDen, you technically have to have 2 separate frequencies. So that's the fight. That's the cat and mouse kind of thing. I don't know. Either or, right? All right, next we're going to go Tetra. And I know we're running out of time, so I'm kind of hurrying up on this. Tetra, what is Tetra? Well, Tetra is a European kind of trunking standard, digital trunking standard, used by F1, okay, which I find kind of interesting. But here's why Tetra is unique. Tetra uses those wide band, those 25 kilohertz bandwidth channels on there, but they can have 4, in essence, time slots running at one time. So what does that mean? Well, what that means is, like DMR had 2 time slots at one point on their 12.5 kilohertz, Tetra on a single frequency can have 4 of them. 4. So they use a TDMA type base thing. So now with Tetra, here's the cool part about Tetra. Tetra allows full duplex. So if you think about it, with a Tetra system, radios usually half duplex. I push to talk, I release to listen. Push to talk, release to listen. Okay? But not with Tetra. Because they have, in essence, 2 extra voice paths, I can have a full duplex conversation. So my radio can be listening to, let's say, time slot 1, and once again, 10,000 foot view here, folks. My radio could be listening to time slot 1 while I'm talking on time slot 2 simultaneously. The other end user on the other one, they're continually listening on time slot 2, but I'm talking on time slot 1. And then same thing. You can then put on time slot 3 or 4, you could do the same thing, but that's for full duplex. Now, if you're not doing full duplex, if you're doing half duplex, push to talk, release to listen, now you can put 4 voice conversations down that same frequency. And this is why F1 tends to use those radios. Because with F1, I found out, and I did a little research. I watched the F1 movie, really. I really like it. That's a different episode, so sorry about that. But in there, when they're doing that, they can actually have data channels go down like time slot 3 and 4, which is feeding their systems on there. As a matter of fact, if they want to, they can actually put data down time slot 2, 3, and 4. And if they're doing half duplex communications, push to talk, release to listen, then what can happen in that case is that they are going ahead and having only one time slot. So now that is very spectrally efficient. Wider, but spectrally efficient in there because now you're putting 4 conversations. But some people may go ahead and also say in there's like, well, wait a minute, can't you do the same thing with NextDen? Well, no, you can. Can't you do the same thing with DMR? No, DMR is only 2 time slots. So it's which way you slice the cake, which way you slice the pie in this situation on there. So that is Tetra. And Tetra is becoming more popular in the U.S. Very, very big in like Eastern or European countries, those kind of things. Tetra is huge over there. Okay. P25 is like, but Tetra is big over there. That's a very big solution on there. All right. Those were commercials. Commercial frequencies or designs can be used in the amateur radio world. They do get used on there. And as we start to see more and more hams are starting to do this more and more and more. Okay. Now let's talk about the amateur-based digital voice modes. And I'm sorry this is going a little bit of a longer episode, but I think this really is going to help a lot of people. So with the amateur-based modes on there, we're going to start out with Yaesu System Fusion. What is Yaesu System Fusion? In essence, it's C4FM and FDMA. It does act very much like P25 and NextDen, but it is not compatible with them. The framing structure, the whole different things of how Yaesu System Fusion operates is a lot more, is a lot different on there. Okay, it's a lot different on there. So you cannot take a Fusion radio and try to talk directly to P25. You can't take a Fusion radio and try to directly talk to NextDen. Okay, even though they're all C4FM. Okay. What they do then in that case is that they have an operation of using either 2 modes on there. So they could use the voice wide mode, which is 12.5 kilohertz, or they can use the DN mode, which is still 12.5 kilohertz, but 6.25 is for voice and 6.25 is for data on there. And that's like forward air correction, those kind of things like that on there. Unlike, P25 having NAC codes and a NextDen having RAN codes, Yaesu System Fusion uses DGID, which DGID is sort of like an access code, a selective access code. So it's kind of like a CTCSS or a DCS on there. It also does allow for connecting of different repeaters and stuff like that on there because there's no, there's no talk group for P25. There's no talk group, unlike P25, I should say, and for Fusion. No talk group in Fusion. P25 has talk groups. NextDen has talk groups. Once again, Fusion does not have any sort of talk group functionality on there. So that is a digital voice designed for amateur radio usage on there. So keep that in mind on there. Once again, because it's designed for amateur radio voice usage, it doesn't go over to the commercial world. Could technically someone probably take any of the amateur modes, put it in a radio, get it certified for it, blah, 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 blah. Yeah, probably. I don't see why the FCC would not allow that on there, but no one's going to do that because there's no, commercial application for the amateur modes. All right, next one we're going to talk to is about M17. So M17 does kind of fall into this 4FSK frequency shift keying kind of deal aspect on there. What M17 is, it's a digital voice. It is an open digital voice protocol. And what that means is, and I'm going to get into that in a second, everything like that in there, is going to be that it does not require, in essence, a commercial vocoder. I'll cover that real quickly at the end here in a moment. That does not mean that it's proprietary. We'll cover that in a moment too, because I hear that so much and I'm like, get off it, folks. Okay. But M17 is in essence kind of a design of having very similar to like what D-Star is with a little bit of flavors of the other digital voice modes on there. So you use an FDMA technology. You're not using time slots, but what you do on there is that you kind of have some selectivity of the call sign routing. That's kind of what you do on there, meaning your access is going to be through reflectors and those aspects of it. So I'm going to say, I want to connect to this person. I want to communicate to this call sign, to this person, those kind of things like that on there. That's sort of what M17 is. Really, to help understand M17, you got to really kind of go a little bit of a deeper dive on there. I'm not doing that here, but understand it is a digital voice mode. It does use kind of the 4FSK type of technology, and it does somewhat use reflectors as a means of communication to who you need to talk to or connect to. And now the final one is going to be D-Star. D-Star was created by the Japan Amateur Radio Relay League, or Japan Amateur Radio League, JARL, which is kind of like a hybrid between ARRL and FCC. And then ICOM went along and picked up on it. I should note that Yaesu System Fusion is obviously a Yaesu branded product. D-Star is obviously an ICOM branded product. While Kenwood does have D-Star radios, they are only doing that based off of the promotional stuff by ICOM on there. So with D-Star, once again, it uses a different encoding. So it's not using 4FSK. It's not using C4FM. It's actually using GMSK. And GMSK is a different type of shift keying, Gaussian medium keying, shift keying. Google GMSK. What you're going to find out is GMSK was very popular for spread spectrum and like the DECT phones of like the mid to late 90s, like Panasonic for cordless phones, those kind of things like that on there, because GMSK worked really well for encoding digital voice on there and doing those kind of things. So in the realm of digital voice, GMSK was like an early starter on there. That has kind of gone by the wayside because they've started to find out C4FM, 4FSK really does a better job than D-Star on there. But D-Star uses GMSK. It does use FDMA. It's not time slot, but it is FDMA. And then from that point on there, D-Star is call sign based or routing based. So in other words, if you want to talk to everybody on a frequency, there is no color codes, NAC codes, RAN codes, DGIDs, nothing like that on there. You would basically have to program your radio to transmit like CQ, CQ, CQ. So what you do is in the call sign, you write CQ, 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 and that's kind of like opens it up to all the different all the different users on there. However, if I want to talk directly to one person only, then I could go and enter the call sign of that person, and then that person we would be able to communicate directly on there without hearing any sort of incidents whatsoever. Now, D-Star does use a narrowband frequency, like a 6.25 kilohertz on there. It is very narrow on there. So it does meet some of that for spectrum efficiency on there. But the operation is completely different, and the vocoders, or I shouldn't say the vocoder, but the digital voice coding is different than all the other modes on there. So that is D-Star. Once again, Yaesu System Fusion, M17, and D-Star are all designed for the purpose of amateur radio applications. Creators of the M17, depends on who you ask for, what time of the day it is, if they're happy or angry. It really is kind of an aspect of like saying, okay, here's the deal. You could use it in commercial if you really wanted to. Someone just had to build the radio to do it. Okay. There's licensing, there's government regulation. What I mean by licensing for that on there, no one is going to pick up M17 for usage in the commercial world. There's not. As you hear, there's DMR, there's P25, there's Nextend, and there's Tetra. The world is already oversaturated with that on there. So not going to really be happening. Sorry to tell you that, folks, on there. I know some people said, public safety could do this better if they did M17. I've heard that by numerous people. No, they got the APCO standard, and that's kind of what they're sticking to. Now, with the exceptions of the amateur band ones, the commercial ones all have trunking aspects on there, which is really popular in the commercial world. There is no trunking in the amateur world per se. Some people have gotten special temporary authorizations to do it and kind of experiment with it, but there really is no main stuff on there right now. So you have those different modes on there. So that's kind of that whole, like I said, quick digestive look at the digital voice modes on there. But I want to bring back a little bit of special kind of thing from the old rebranded version when it used to be Communications and Cigars, because I think it would be funny to talk about this next topic about vocoding and proprietarism. You know what really bends my antenna? You know what really bends my antenna is really this aspect, and this is the opinion part of myself, so I just want to clarify that, is this whole debate on what is proprietary and what isn't proprietary. I hear this as try to people do a selling point for things for so long, and I'm going to tell you what, people, just because a radio manufacturer makes a digital voice mode or uses a digital voice mode does A, not make it proprietary, and B, does not fit the definition of proprietary, okay? Really, the definition of proprietary is one that is of a closed aspect of a mindset or the ability to do things, okay? So proprietary would say you can't do this without either my express written authorization or us allowing it to do it for you, okay? That's kind of the aspects of proprietary. Now, what digital voice modes require, except for M17, is a vocoder. Okay, a vocoder is a voice encoder and decoder. That's why it's vocoder. Okay, voice encoder decoder. All right. So, with that, yes, do digital voice modes require that vocoder? Yes. Is there currently only one company that's making vocoders now? Yes, DVSI. However, we are in the days and ages of software-defined radios and stuff like that. There are people who are able to take and duplicate the modes of all of them, not just amateur, not just commercial, but all of them, and be able to use them in this regard to saying, okay, hey, here's the deal. You can actually take and use this on a radio or a piece of software without a vocoder because it's all software-defined. Okay? But once again, the excuse of, well, there's only one brand of radio that makes this radio, makes it close. No, it's not. It's not. And I'm going to tell you how even more so on there. I'm going to show this on here. This is a little Zoom spot stick that I picked up really inexpensively. Okay, this can do all the digital voice modes. Okay? If the digital voice modes, the framing, the understanding, the aspects of it were proprietary, that device would not be able to do that unless they bought royalties. And they are not buying royalties. Those MMDVM boards, not buying royalties or permission from any of the different digital voice mode manufacturers or anything like that on there. So the whole thing about it being proprietary and stuff like that, no, not correct. Anybody can build a digital radio if they want to and use any of the digital modes. Some do. Once again, DMR is very popular for that. P25's Tetra, very big in the UK. Lots of different manufacturers on there. NextDen and IDAS, okay? NextDen and IDAS, yes, only made by Kenwood and ICOM, but that doesn't mean it's proprietary to Kenwood and ICOM only. Do some company do some things, put spins on it to make it like, oh, yeah, well, hey, if you buy the radio for us for this mode instead of buying it from the other competition, we can do this with our radios where that competition can't. Yeah, that's selling the sizzle of it, right? That's the mushrooms and the onions on the steak, right? Everything at core is the steak, but the additional things that are on there. So this whole thing about it's proprietary, no, BS. You could go build a Fusion radio. You could go build a D-Star radio. You could go build a DMR radio, when people have, right? P25, NextDen, Tetra, all those. You can build those radios and put those modes in without paying it. But if the hardware is not automatic, makes a mode or technology proprietary, it doesn't automatically. Some cases it will, but in this case, you don't have to use that simple vocoder. People are doing it via software and other means. And if they're doing it via software and other means without usage of the vocoder, that goes ahead and shows that guess what? It's not proprietary because proprietary would state certain things that have to be done to it. So that is what's on this part of, you know what really bends my antenna? And for those that have came up to me and said they would really like to see it again, cool. There it is. It's back there to you. Now, I know the episode went a little bit long here. We're almost at an hour here. I do apologize, but it is more of one of those in-depth episodes on there. We're going to explore digital voice a little bit more because I keep hearing different people and different things kind of get it wrong. So we are going to start to break down some of the modes here more and more as we go along from there. But at that time right now, it is getting that there. Once again, thank you for going ahead and sticking with me on this. I know sometimes it can be a little dry, it can be a little boring, especially if it's a mode that you don't like or a mode that you don't want. But guess what? It's the way that the world's going on there. Scanners, receivers, stuff like that now you can buy that cover all of these modes here, which, once again, by the way, proves that proprietary stuff is not there. So, until then, everybody, thanks for coming back to the show. We still have more shows coming. Take care. Stay safe. Let's talk on the radio sometime.